This is Mayank, and I welcome you all to Srijan Wednesday webinars. For those who are attending for the first time, this is a community initiative by Srijan Technologies. As a part of this initiative, we host webinars every alternate Wednesday. We have speakers from different domains who talk about subjects like front-end technologies, UI UX, mobile apps, media, entrepreneurship, digital marketing, and many more. Today's webinar, titled Architectural Decisions Serving the Thundering Herd, is focused on the immediate impact of events on the internet. This immediacy leads to either organizations being unprepared for traffic or end up building over-engineered systems which are hard to maintain. In the first 40 minutes, the speaker in this webinar will provide valuable pointers and resources that can assist in achieving high-performance systems, along with concrete examples of choices made at Jabong. He will also give guidelines to keep in mind so the system scales elegantly with room to optimize even when traffic increases. The last 50 minutes will be for a Q&A round. I request you all to please type in any questions that you have during the presentation, and we will take them up towards the end of the session. I would now like to introduce our speaker for today's webinar. We have with us Supreet Sethi. Supreet is the technical architect at Jabong, where he steers platforms, teams to create tools that drive Jabong's infrastructure. He often reviews the code base from a performance point of view, which puts him at the helm of backend systems and APIs which drive Jabong's mobile app, mobile web, and desktop site. Supreet has proven expertise in charting out growth strategy for technology platforms and is a seasoned technology leader with an eye for details. Without taking up any more time, we'll get started. Supreet, over to you.
Thanks, Mayank. I hope I'm clear. I'm not very used to the whole idea of doing a webinar, so I would really love if it's as interactive as we can make it. I'll give you a bit of a background of when I started out in Jabong, what was the kind of platform it was over a period of 6-7 months, what is the kind of work that we have done, and that I would like to make as an illustrative case for what can be done to scale platforms, hence the whole idea of architectural decisions. Jabong is a Rocket internet funded platform for fashion in India. It's quite well known. Rocket, apart from funding the venture, also provides technical know-how, and hence Jabong has a legacy of a system coming from Rocket Internet. So over a period of 2 years, from 2012 until 2014, the legacy system from Rocket Internet was being used, and it was successfully deployed for creating the fashion destination that Jabong is. But during these periods, individuals realized that it wasn't good enough, and there was a requirement to build better platform, because in certain senses Rocket Internet itself didn't envisage that this venture would be that successful. And this is where I was brought in to look at the kind of pain points that were faced by the legacy system and how those could be addressed. Before we delve into the details, I have this quote from Donald Knuth, who is a well-known academic, a programmer. He's written extremely good papers on algorithms. Some of the most well-known algorithms were devised by him, and his words about optimization are pretty important when it comes to the whole idea of architectural design. And I would illustratively state that keeping it simple always works better than putting complex systems which have unknown parameters to people who are putting them in. So moving on, these are few numbers that are there. Jabong currently does 28,000 requests per minute, which is an astoundingly high number, of which there is still, I mean, I'm leaving out things like static files. I'm leaving out various kinds of assets which are not coming from Jabong's own platform. So it forms roughly about 40% of our traffic. Rest of it comes from different properties, including static image sites, partner sites. So this is number from the primary site that we run. Average page load time on desktop site is about 7 seconds. This is after loading about 50 images, let's say in catalog pages. It's 14th most visited site in India, and the numbers are astounding, and this is all being served out of strangely few servers. And I am in certain senses revealing the secret sauce that we have regarding scaling our platform. I would love to take question on every slide transition. Mayank, sorry.
Yes, Supreet.
Yeah, I just wanted to quickly state that what would be the protocol about that?
I would like to announce that for every slide transition, in case you have any questions, please type in the questions panel on the GoToWebinar window, or just press the raise hand button.
Yeah, great. Thanks, Mayank. So let's look at sizing and planning, because generally when you start off, let me step back a little. When you are looking at the idea of scaling, there is a very strong understanding that you have reached a certain point where there is already a success. So there are a few assumptions that I'm making, that people who are attending this session have already achieved a level of success by building a product that users want to use. They have enough resources to be able to say that one spare AWS server or few spare AWS servers are not a very large investment to make. It's bit costly, but I get something done. So these are the kind of assumptions I'm making, which generally hold true, because by the time the kind of problems that I'm talking about you are able to find, you have reached a point where your traffic is pretty high and you are essentially making quite a bit of money. So let's look at a few of the resource planning that needs to be done before you start looking at scaling. Network, essentially when we talk about network, we talk about two ideas. One is latency and another is bandwidth. Now bandwidth essentially means that from point A to B, how big is the road? If we take a parallels of road, which is in certain senses quite accurate, and bandwidth is the width of the road, whereas the distance between point A and B is latency. Within this simple framework, there are strange things that happen. Like take for example, and this is one of my favorite points that I make, is that in case someone is using, one of the clients of your website is using Google DNS, the kind of routing or the latency that you'll see on your website would be strangely high, especially in India, because Google DNS actually routes via Japan or Malaysia. And when that happens, all the caching websites or CDNs that generally websites use tend to assume that the website exists, the client exists in Japan, and try to serve resources from Japan or Malaysian CDNs. And as an Indian service provider, that means the amount of distance or the latency between you and your client, a consumer, becomes really high. So these are kind of subtle but important decisions that need to be made, which include things like where do you put your data center, who are your CDN data providers, whom do you decide to use as a network provider, or where do you buy your bandwidth from. Similarly, traffic split on different platforms. IOPS is a big limit on the systems, because you can buy more CPU, you can buy more RAM, but hard disk speeds are not growing at as fast a pace as CPU and RAM are. Relatively speaking, getting the same speeds for hard drive is exceptionally costly compared to buying more CPU or RAM. Another important criterion is to understand your consumer. You know, the people who are coming to your website, your mobile platform, your mobile sites. The understanding of how they are coming, why they are coming, can contribute very strongly to the sizing and planning. Moving on, these are the predominant tool set. I have actually kept a very small set of tools. In Jabong, we use much bigger sort of ecosystem. So these are the kind of tools that come really handy while you are designing, and scaling your platform. Memcache, essentially for caching your objects that you are serving to the consumer in RAM. Redis follows the same pattern. You also serve data through RAM. Redis has an interesting, addition to Memcache, where you can actually store data structures into Redis. In case of Memcache, it's a blob that you're storing, and your programming language is supposed to evaluate it in certain senses. MC router is one of the key features that we use on our platform and can be very interesting in conjugation of Memcache, because MC router allows you to propagate your caches with various strategies. It's a tool coming from Facebook. It's been battle tested and it's not well known. Interestingly, in Jabong, we have modified MC router for our use, and we find that the changes that we have done at Jabong are quite useful. And I would highly recommend that you should look at Jabong's repository of MC router in case you want to try it out. Message queues are strongly recommended for especially doing async work. I am not a very big fan of asynchronity style that is propagated by Node.js. In Jabong, we use Go and PHP. PHP does not even support that kind of model. In Go, various complex models of asynchronity are supported, and it performs better than Node. And message queue as a combination with PHP and Go provides us the similar level of quality as one would expect from Node.js based website. Varnish we use for internal caching. AWS services we use widely for static platforms. We serve via CDNs. Akamai is our key CDN, but we also use various others, including CrowdFront from Amazon, Searchlight, Couchbase, similar to Memcache. We can have a longer conversation about these tools and also about other tools that we use in Jabong. Now, coming back to the whole idea of speed, scaling, architectural design, the amount of resources that development resources that we have are limited, and making a site fully scalable is generally close to impossible, because there are points at which you are doing a transaction, and transactions are fairly expensive, and there is no way to easily scale them up. Whereas when somebody is visiting a home page, in our case catalog page, product page, these are the kind of pages which are visited much often, and they are formed the top of the funnel. Here I'm talking about the whole idea of a funnel, where top of the funnel is individuals who actually have come to the website or the mobile platform, whereas the bottom of the funnel are individuals who are interested in a product, they have added it in a cart, or they have liked that product. So the moment user has reached a point where he's shown clear interest in buying or saving a particular product, he becomes more valuable. And because the quantum of users of that kind is much lesser, the scaling issues become much lower. So one needs to realize that you have finite resources and you need to invest more on scaling on the top layer, whereas on bottom layer one, it's extremely costly to scale, and it also entails kind of premature optimization, and it's hard to debug things if they go wrong. So in our case in Jabong, we heavily invest in home page, catalog page, product page, because they form more than 80% of our traffic. And if we are able to scale that, we may not have to deal with scaling other resources, because for a simple reason that we vacate so much resource once we have optimized these pages that those can be used for these critical tasks. Moving on. Programming strategy. I have actually kept the whole idea abstract. I haven't really addressed from a point of view of a particular programming language, because these choices of language really depend on the kind of talent you can acquire. If you have a prior platform, if you have a preference for a vendor. So I'm defining most of these problems on a very abstract level, and we can in the end take up concrete examples of how we addressed in specific case of Jabong, where we use predominantly Go and PHP as our programming platform. So you define the bottlenecks. Bottlenecks can include things like on a top of the funnel, these could include database calls, because at high traffic conditions, making database calls can be fairly expensive. You look at candidate solutions, try them out, but here is the issue. Many times what happens is that one decides to try them out one or two together or three together, where you are not able to actually see the end result clearly, because you know the system is actually testing out more than one facet, and then deploying in production. And this cycle continues. You need to rinse and repeat. Same thing again. Unit testing. So often what happens is that you have decided to build system or refactor system or rebuild the system. In our case, we did something for our static image serving, which we had to rebuild the whole system. The importance is to actually be able to separate the business logic from your web interfaces. It can be done through an abstract request response interface, which is often available in Java servlets. It's available in PHP, it's available in Go, it's available in pretty much every language. If you make it abstract, the amount of testing, rigorous testing that can be done on that module increases quickly, because testing it out on a browser is a slow process. Whereas if you have automated tests which use these abstract request response handlers, it's quick to test out if you're doing the right thing. Staging and deployment. Now, in this particular case, it's very hard to replicate the scale. Now, everything else is easy to replicate. It's easy to replicate business logic errors. It's easy to replicate typical bugs that occur in software development. But replicating the size of traffic that you're going to receive is a hard problem by itself. You can use JMeter to replicate few things, but then you are building caching in the pipeline. So, you know, most of your data would cache after first or second request. But essentially, you will not be able to test the web handlers, you will not be able to test the request response interfaces until you are able to replay the same scale. And to do that, in our case, we often use the load balancer. Our load balancer allows us to capture logs, and then we replay that in staging server to be able to verify whether our code is performing well or not under scale. Formal verification is a process where you actually try to reason how the code works. Where what happens is that you essentially refactor your code into two parts, where there are parts which have no side effects. So a function receives some data and just outputs that something else. Whereas there are functions which receive data, they output something, and they also have side effects. Like, take for example, you're writing a file. It always sends a normal or an error, but it also writes data onto disk. So these verification process requires the idea of separating concerns. Ones where you have pure functions which have input and output and no side effects, and then impure functions. We actually do things like IO, they do database entries. Those kinds of functions should have separation so that you can do formal verification of code. Coming to lessons learned. One thing is pretty clear, that many of the assertions that we make on a day-to-day basis on how system are on scale, many of these assertions are plain wrong. And quicker we admit it, better we are. So things will fail. To ensure that that does not hamper the systems is to make sure you have a rigorous process of rolling out and having a backup of your platform code base to be able to switch over quickly. Most of the people would be resourceful enough to actually have more than one server serving the web platform or mobile platform. So you test it out on one server, and if it fails, you stop the rollout there. And if it doesn't, you keep going. On scale, bugs are become really evident. To cite an example, um, on our image systems, we produce small images out of large images, and during this process, a lot of RAM gets consumed by the large images that we use to process the smaller ones. Now this RAM over a period of time can kill the system, because we are not actually removing the images out of the, we were not removing images out when we were producing these smaller images. And these bugs were visible in minutes when we went into production, but they were not evident enough when we were trying it out. So scale lends itself very well to getting to know what are the kind of bugs in the system. Another learning which relates to this one is, if we have systems which have high resources when we are testing, we will not be able to face the problems that may occur on scale. It's better to have system which is low on resources, and the bugs will become more evident, and the system actually becomes more similar to how things will work on scale, because resource per user is much lower, is on a much lower threshold on a production system than it would be on a development site. System understanding, like I'm pointing it out, is an extremely important criterion. Understanding the system also means keeping it simple, having extremely good DevOps people who can take care, have a strategy. And here, I mean, it's fatal to say that system is working, I'm going to switch on and switch off if things go wrong, because it's happening once a week. Ideal situation is to address problem as quickly as possible, because moment you are saying that things are going wrong and there is no predictability in it, then there is a possibility that the system can get, go down, and you would have no trace of what's happening. So these are 3 make-its that we have in our platforms team in Jabong. Make it work, make it visible, make it DevOps. Make it work here encapsulates the idea of testing, being rigorous with code, having right abstractions, keeping it simple. Make it visible, we quickly try to deploy and see what works, what doesn't work. Like I pointed out again earlier, that's at scale, the kind of bugs that you'll find, it's harder to replicate them when you are in dev mode. Make it DevOps here is predominantly the idea of making it production ready, which means that if you're writing a service, write a supervisor interface, writing deployment scripts. I think making that quality also lends itself extremely well to having a good production system. Thank you guys. I don't know if Mayank?
Yeah.
Hello.
Well, that was a great session. Thank you, Supreet, for sharing these insights on performance optimization and how organizations can minimize development and infrastructure costs. Moving on, I'm sure you all have a few questions. Please press the raise hand button on the control panel to ask the question using your microphone, or type it in the chat box on your screen. Supreet, we have a question by Satish, who wants to know if you use any third-party PHP frameworks or CMS. I believe he's referring to Jabong.
At Jabong, we use Zen framework, and we don't use any other third-party platform per se. there has always been a rumor that Jabong uses Magento. That's entirely untrue. Yeah.
Thank you for answering that. So he also wants to know what monitoring tools do you use on servers?
Excellent question. That's a point where I didn't want to specifically point at certain tools, because most of these are services, paid services, and I don't want to advertise any specific one. Most of these services are extremely good. In our case, we use New Relic, we use Datadog, and a service from a service script from XA called StatsD, uh, which provides real-time monitoring. We also use Monin for monitoring.
Satish also wants to know, how do you manage releases on servers?
We have a rolling release system where we release, we make sure that we have a release once a week, and during this release we try to make it a bunch of features from which have been tested together. There are this I'm talking about the code base. So there is code base, which is primary desktop site, and then there are services which are independently working in this SOA ecosystem. So these services are independent of this release system. They have their own independent releases.
Vivek Mantri wants to know, is there any downtime at release time?
Not really, because what we do is that we have set of servers, and load balancer, from load balancer we inform that this server is out of service. We roll out and then put it back into service, and hence we are able to have zero downtime during rollouts.
Thank you for answering that. Supreet, since the questions are coming in, do you mind giving us a quick recap of the presentation for
Sure.
attendees who
Actually,
joined a little late?
I would like to go back to the Toolset and Services and give you real life examples of what we are doing with it. Memcache is, we are using as a speed, it's like a service which where we store our product assets, and we serve from Memcache instead of calling MySQL, which is our backend database. So most of our product and web pages come out of Memcache. Similarly, Redis and Couchbase. We use MC router to propagate data from our database to Memcache. Message queues we use for in our environment. We've been using it for various things, including propagating static images when we add a new product. We use it for logging analytics. We use AWS services extensively because we feel that there is a huge value in some of the services that they have. We use Elastic Compute a lot. We use their storage services a lot. So while not advertising Amazon services, I would say that in our case we find them extremely good. They fit into our ecosystem very well. We use Akamai extensively. Most of our site is served via Akamai. We have started using Aerospike. It's a database which is cutting edge. It's a replacement for Mongo, and we have found that it's faster than Mongo, especially on writes. Like I mentioned, for monitoring we use New Relic and Datadog services. So these are the kind of key ecosystem changes that we've brought in to be able to scale really well. Yeah.
So Vivek wants to know, how do you manage to give release in a certain period of time? Let's say when you have offers for Diwali or some regional releases.
Yeah.
In a short period of time. I believe that's what he means.
So that's an interesting question, and the answer to that is you make these things reusable platforms instead of being part of code. So these are configuration options instead of being code. So there isn't a programmer needing to sit and write a Diwali offer. So the platform is flexible enough that we can roll out a Diwali offer without having a programmer sitting and doing some code. That's how we are able to do it on a quick basis. If there is a programming involved in this thing, then it will be close to impossible to be agile when it comes to these offers. Internally, we also have offer static page designer of sorts, where we can quickly design pages, offer pages, and there is no programming intervention. There is a workflow around it which we have built in-house, which verifies if it's compatible with the convention of Jabong pages, then it pushes the images out to our static servers, then it pushes the page onto production. So there is a proper workflow. If one would want to build something, not build something like this, I would suggest something like Adobe CQ5 to do that. Yeah.
Lalit wants to know your thoughts on ArangoDB.
On which DB?
That's Arango, ARANGODB.
I have no idea. I haven't used it, so I can't say.
He also wants to know that how are you using Aerospike in your architecture?
So Aerospike we use with combination of message queues. What we do is that we analytics data is pushed out by the website and the mobile properties and mobile APIs onto a message queue, and we have slave processes, workers, which pick that up and push them into Aerospike, which we eventually use in conjugation with Hadoop Hive to process the data. That's our analytics pipeline. Yeah.
Lalit wants to know whether Jabong has a DevOps team or the developers are writing deployment scripts.
We do have both. In case of platforms team often deploys themselves. They know, they have a good understanding of DevOps. In case of our primary code base, there is a dedicated DevOps team for that. So there is always assistance available from DevOps team, but there are several pieces which are independently deployed by programmers themselves.
Ankit wants to know whether there is a specific way to tackle large outbursts of traffic during offer seasons.
So That's a good question. Let me go back to one of the slides, which is this one. And I would like to point out the whole idea of a funnel. So when we are in a burst situation where there's a lot of traffic coming in, essentially what is happening is that the funnel is becoming larger and you are receiving a lot of traffic on top of the funnel. And if you are able to hold on to that traffic, generally your bottom end of the funnel does not have that much bottleneck. It's, if you are let's say getting million users, let's say you're getting 100 users, out of which 1% converts into actual transaction. When you are getting 200 users, it's only matter of handling double of that traffic, but double of that traffic is still fairly easy to handle with your resources. It's the top of the funnel which becomes a problem, and from that perspective, the whole idea of not having to hit the disk to be able to serve data is extremely important. If you're serving pretty much everything from RAM, you can handle high traffic very easily. To give you a parallels between CPU and RAM, if the distance is here to Bangalore, then CPU to disk would be here to California, possibly more. So the expense becomes much higher, and hence database in such cases becomes a huge bottleneck. Having memcache, having extremely good cache propagation system helps in most cases. Yeah.
Vivek Mantri has another question.
Yeah.
He wants to know, what if the system crashes? What is a strategy to get it up quickly, and how much time does it ideally take?
Are we looking at specifically Jabong or as a general strategy?
I believe as a general strategy. There's no mention of Jabong.
So generally it's a business continuity problem, really. So as anyone who is building a business, it's important to have replication, to have DR, a BCP, business continuation system. What would be ideal to have is a slave database somewhere in another data center, and have a standby system which can go online depending on the kind of services you are running, from a day to within few seconds. An option would be to run cheap AWS servers, to have a data center, let's say in India, and have another data center in Singapore. I'm specifically saying Singapore because the distance between India and Singapore, latency-wise, is quite low, especially in specific case of South India. So that's an ideal strategy. Apart from that, you have your backups, online, offline. That goes without saying. Yeah.
Thank you, sir. Thank you, sir. While more questions are coming in, is there any specific part of the presentation that you would want to give a recap of?
I'm just wondering if I missed out on something. Well, another service that I would really love to talk about is StatsD and Datadog. Generally what happens is that um, one tends to log either from an idea of being able to analyze user, or you log services via running a error log of some sort. These are great methods, but they are fairly subjective. So from the point that the error occurs to the point where you can address it becomes very long. And this is where we find StatsD is an extremely good service to have. So what it does is that you can program in or instrument your system with counters, timers, saying this much time it took to, let's say, process an image. This much number of requests are being attended to right now. This many threads are being run on the system. So StatsD allows you to cheaply be able to push this data out into your monitoring tool. And when I say cheaply, there is a reasoning behind it. What happens is that the moment you're making a TCP connection to send this data out, you are actually blocking your service until that data goes out. Whereas in case of StatsD, what happens is that the data is pushed out on UDP. So if it doesn't arrive, nobody is going to shoot you. Hence, the service can continue working while it's pushing this data out, and that doesn't harm the turnaround time of the service, and yet you are able to get real-time meaningful data to exercise on what might be going wrong or what might be going right, in case you are able to successfully come up with architectural design. So it's a good feedback mechanism which works in conjugation of trying things quickly. Yeah.
Lalit wants to know if you would like to share some insight on TDD at Jabong.
So I don't particularly believe in XDDD category of programming. I think talent trumps over many of the driven development kind of thing that we are talking about. Processes, yes, we follow agile process at Jabong, which includes having sprints, having the whole testing cycles, but we don't follow TDD per se. And having said that, TDD is followed for certain services that we run. So we have a model for building unit tests first and doing integration modeling and be able to build an API. Those kinds of things are being done for certain services, but apart from that, the main code base runs on a typical agile model, and we have testing teams which has automated testing, sanity, yeah.
Satish,
I don't know if
wants to. Sorry, you were saying something.
No, I don't know if I answered the question enough, or if there is.
Lalit, in case you have a follow-up question, please feel free to type in. Satish wants to know how many total servers you have on production and what is their configuration.
It's almost embarrassing how many servers we have, because frankly, when we look at the number of servers we have and you can speculatively talk about the number of servers that some of your competitors have. It's just embarrassingly small number that we have. I think the whole system is under 100 servers. And there are few reasonings why that is the case compared to how the strategy that competitors have been following. But yeah, that's the case. I mean, in sheer numbers, it's less than 100.
Thank you, Supreet. Lalit has a question. So it's a personal question, that what all technologies would you love to work in the near future?
I have been working on Aerospike in recent times, and I find it an extremely good tool to play around with. And in conjugation with Go, which is the language of preferred language right now, I am looking forward to some of the language work that is being done at Mozilla, which is they are planning to build a language which could be a replacement to C++, and any replacement to C++ is refreshing, because Java is the only replacement right now, and Java doesn't look that attractive. So we have Go, which is well integrated with Linux environment, and which is my primary environment to work on, but it has some shortcomings. Having said that, it's a great language for server application development. But I also look forward to Rust as a platform which is being built by Mozilla. What else am I looking at? I'm really excited about the whole idea of being able to test via things like Phantom.js, Ghost. These are the kind of services which are extremely useful to see how the browser behaves, and being currently working a lot on web stack, it's really important to understand behavior of the browser, and there is so much variance in between even the three major platforms that we support, Chrome, Opera, and Mozilla, that being able to test these out in an automated fashion would be a great relief, because it takes away a lot of time to just see what's happening on a browser.
Since we are running towards the end of the webinar, I would request those who still have questions to please mail them at webinars@srijan.in. We have typed in the ID in your chat box. Thank you once again, Supreet, for such a knowledgeable session. We are sure everyone found your presentation very interesting and insightful. A big thank you to all the attendees for joining us in today's webinar. I would also like to announce that the next webinar is on lean user experience for minimum viable products on the 12th of November by Ravi Sohag, who is an award-winning web architect, designer, developer, hardware hacker, and entrepreneur. In this webinar, Ravi will cover different aspects, tools, and methodologies of lean UX that should be adopted for designing MVPs. We'll be sending you the registration link along with more details in a subsequent mail, so stay tuned.
Yeah, thank you, Mayank. Thank you, Priyanka, for being quite helpful, and thank you all for being patient listener and for your questions.
Thank you, Supreet. Please take care.
Yeah, thanks.